Yes, welcome to Mwalimu Wetu, an online platform for learning. Today we want to do chemistry, that is back titration. So the question reads, you are provided with 3.6 grams of impure calcium carbonate, solid A, 2 molar HCl, solution B, 0.05 sodium hydroxide, solution C. You are required to determine molarity of solution C, percentage purity of solution A. Procedure. Using 100 ml measuring cylinder, measure 40 cubic centimeter of solution B and transfer it into a 50 cubic centimeter beaker. Add all solid A into the beaker and agitate carefully, to mean that you will be shaking like this carefully until no more effervescence is produced. Transfer the solution into a 250 ml volumetric flask and top up to the mark with distilled water. Label it solution D. Fill the burette with solution D. Pipette 25 ml of solution C into the clean conical flask and add 3 drops of methyl orange. Methyl orange is an indicator, and indicators are always used to determine the endpoint. Titrate solution C against solution D and record the results in the table below. Repeat the procedure 2 more times. So what is here, as you can see, what you are required to determine percentage purity of solution A, and this is back titration. So to mean that you first react the carbonate with the hydrochloric acid, and then after reaction with the acid, the moles that remains, you neutralize some amount of the moles that remains with an unknown amount of sodium hydroxide. So you are going to start from the back, whereby you are going to use the quantity of sodium hydroxide that used to neutralize the acid, and then through the mole ratio you are going to get your answers. So let's say, for example, we are just going to guess our volumes. Let us guess our volumes. Let's take, for example, in this case, let us take the step 1, the burette reading. Let us take it to the final to be 41.2. Initial burette reading, let's take, for example, to be 20.0, and then the volume that was used is 21.2. Let us take this one to be about 38.5, and then this one may be, let's take for example, let us take initial burette reading to be 17.3, and then volume use is 21.2. Let us take the final burette reading in this case to be maybe, let's take for example 45.2, and in this case it may be 24.0. So the volume of the solution B used is 21.2. So in calculating the average volume is equals to in this case the difference is they are just in the same range. When calculating average volume, you should include those ones that are in the difference of plus or minus 0.2. But in this case, 21.2 plus 21.2 plus 21.2 over 3. The answer is equals to 21.2 cubic centimeter. The answer is equals to 21.2 cubic centimeter. So the next question. Calculate the number of moles of solution C used. Solution C was the 0.05 molar sodium hydroxide, and we took 25 cubic centimeter of solution C. So you know that moles is equals to volume times molarity over 1000. So the moles will be, volume was 25 times molarity, that is 0.05 over 1000. The answer should be 25 times 0.05 divided by 1000. 0.00125 moles. That is correct. And then calculate the number of moles of the acid in solution D solution. Solution D is the solution that was neutralized by the sodium hydroxide. So you just write the equation for the reaction. HCl plus sodium hydroxide is equals to sodium chloride plus water. The mole ratio is 1 to 1. So to mean that the same moles that reacted in the same moles that 0.00125, mole ratio is 1 to 1, the same will be 0.00125. So the answer is equal to 0.00125 moles. Calculate the number of moles of the acid into 50 cubic. It asks that calculate the number of moles of the acid into 50 cubic centimeter of solution D. So you just say that if the average volume was 21.2, so you say that if 21.2 cubic centimeter contains 0.00125 moles. To 50 cubic centimeter will carry we cross multiply. To 50 cubic centimeter times 0.00125 moles over 21.2 cubic centimeter. Okay, a simple calculation. 250 times 2.00125 divided by 21.2. So the moles of the acid that was contained into 50 cubic centimeter is 0.014741 moles. See it clearly? So that is it. Calculate the number of moles of HCl in 40 cubic centimeter of solution D. You know that in solution B, molarity of solution B, molarity is equals to 2 molar. 2. So it was 2 molar HCl and 40 cubic centimeter. So you just say that moles is equals to molarity times volume over 1000. So it will be, moles will be 2 over 1000. Answer is 0.08 moles. 0.08 moles. So to mean that these are the moles that were contained in the original solution before reaction with the carbonate, while these are the moles that were contained in the solution after reaction with the carbonate, because the solution D was made after reaction with the carbonate. So these are the moles that was contained after reaction with the carbonate, while these were the moles that were contained before reaction with the original solution, before reaction with the carbonate. And then calculate the number of moles of the acid that reacted with the carbonate. So the equation of the reaction, I'm just going to write the equation of the reaction. The moles equation of the reaction, just write that HCl plus calcium carbonate is equals to calcium chloride plus CO2 plus water. If you balance the equation, and you have found that not writing the equation, I'm sorry for that. Moles that reacted with the carbonate is equals to moles before reaction minus moles after reaction. That is 0.08 minus 0.014741. Answer will be minus 0.0. So the answer is 0. Remember, most of the acid that reacted with the carbonate is 0.065 to 59 moles. Those are the most of the acid that reacted with the carbonate. So you can check check. And then the next question is asking, calculate the number of moles of the carbonate that reacted with the acid. The moles of the carbonate that reacted with the acid. Just write the equation for the reaction. HCl plus calcium carbonate is equals to calcium chloride plus carbon dioxide plus water. If you balance the equation, it will be 2. And the moles of the acid that reacted with the carbonate was 0.06526, to mean that the mole ratio is 2 to 1. So to mean that if 2 is equals to 0.06526, 1 will be what? Upper 1 will be 0.0263. So these are the moles of the carbonate that reacted with the acid. Calculate the mass of the carbonate. You know that moles is equals to mass over RFM. It means that mass is equals to moles times RFM. So mass is equals to moles, that is 0.03263 times RFM, that is 100. So the answer should be 3.263 grams. That is the mass of the carbonate that reacted with the acid. That is the mass of the carbonate that reacted with the acid. That is the mass of the carbonate that reacted with the acid. Calculate the percentage purity. Calculate the mass of the impurity in the mixture. Original is 3.6, while the pure one, so the whole carbonate is 3.6, while the pure one is 3.263. So the mass of the impurity will be 3.6 minus 3.263. Mass of the impurity is equal to 0.337 grams. Calculate the percentage purity of calcium carbonate. Percentage purity is equals to pure mass over total mass times 100, to mean that is equals to pure mass, that is 3.263, over pure mass, that is 3.6 times 100. Answer is equals to 90.64%. And then the equation is over. So just observe it. That is the average volume. After the average volume, then let us go to the moles. Observe it. Pole. Observe it.